3.4, differentiating inverse trigonometric functions. So we're going to take the derivative of arcsecant 6x. So first we look at this chart for arcsecant, and it's right here. So it tells us to first take the derivative of the inside. So we're going to take the derivative of that, put it on top. So that will be my first step. So it's going to be a fraction. The derivative of 6x is just 6. Okay. Then we take the absolute value of u, which is 6x. Then we put the square root of u, which is 6x squared, minus 1. Now, be careful. It's really important that you put the 6x in parentheses. Got it? A lot of people don't, and that's where they make mistakes. Now, next, could you drop the absolute value? No, because x, there'll be some in the future where you can drop the absolute value, but in this situation, you can't. But what you could do here is technically, could you take the 6 outside the absolute value? Because isn't 6 always 6? Just think about that. So could we technically put the 6 here? Could we pull the 6 out, leave the absolute value x, and won't this right here be the square root of 36x squared minus 1? Now could we cross those out and rewrite this as 1 over that square root of 36x minus 1? That right there is a better cleaned up answer. But you could have left the original. You could have left this. Got it? If it's delta math. You could have, but a lot of times they'll write, I'm saying more like multiple choice test questions. They could have gone all the way to here. The red is fine. Got it? The red is fine, but they'll probably go to here. So let's take the derivative of arcsine of cosine x. Oh my goodness. A trig inside of a trig. Interesting. Very interesting. You can do that though. So according to the formulas, let's look for arcsine. Arcsine's right here. So we're going to use this formula right here. So let's plug it in. That's going to be u prime. So the derivative of cosine is negative sine. So that's the top, negative sine x. Over, according to the formula, the square root of 1 minus cosine x squared. And could we rewrite that a little bit clearer? Yeah. Are we doing it at a number? No, we're done there. So let's clean this up. Isn't this going to be negative sine x over 1, the square root of 1 minus cosine squared x. So you might say that's done. But I want to show you something that they could do. That is an answer. But this actually simplifies. Did you know this right here is really sine squared? That really is sine squared. Okay? So what we have now is negative sine x over the square root of sine squared x. Now, how did I know that was sine squared? It's called Pythagorean identity. And what's the square root of sine? What's the square root of sine squared? Oh, that, my friends, is negative sine x over sine x. And what is anything over itself? Negative 1. So that right there would trip some of you up. You'd be like, how'd they get negative 1 as an answer? Oh. It is. So what they're saying is this graph has a slope of negative 1 all the time. If you graphed it, it's like, what? Yeah, it's kind of weird. But that is what they're getting. So sometimes this is fine. Sometimes this is fine. Sometimes they simplify it down. Just be aware on delta math they won't. But on, yeah, you have to just be careful on what kind of problems when they simplify and do it when they need to. All right. If g is the arctangent of x squared, what is g prime 1? So let's first find the derivative of this and then plug in 1. So first we want to look for where's arctangent? It's right up here. So we're going to use that formula. All right, so we take the derivative of the inside first. So that would be 2x over, and then we do 1 plus something squared, where we're going to use leave the x squared there. All right, so we just leave that in the inside here, but we take the derivative on top. And this is the derivative of g. So let me write that. That would be g prime x equals. So we just took the derivative. Now, as you can see, we want to plug in 1. So to plug in 1, it's going to be 2 times 1 over 1 plus 1 squared, which is going to be 2 over 2, which ends up being 1. My slope is 1 at 1 for g. All right, the next problem. What you have to realize here is f is the inverse of cosecant. All right, and then look at this. What does this mean? Well, when you see this, you have to be good at interpreting this limit is really a derivative. This is really just saying f prime 2. You have to understand this is saying the slope of f at 2, or the instantaneous rate change of f at 2. So if we know f is here, can't we take the derivative of this and plug in 2? And so to do that, we're going to use the formula at the top. We've got to find cosecant. So cosecant is right there, or inverse cosecant, arc cosecant. So since it's just x inside, that's actually pretty easy. The derivative, f prime x is equal to, the derivative of x is 1, but that's going to be a negative 1 according to the formula. The absolute value of x times the square root of u, which is x squared minus 1. So that right there is my derivative. But then I want f prime 2. So to find f prime 2, I'm going to plug in 2 to everywhere I see an x. So I'm going to do that real quick. And when I do this, I get negative 1 over 2, because the absolute value of 2 is 2. And this would be the square root of 3. And that is a good answer. Now, you might want to break this down and get the square root out of the bottom, just in case, like on an AP test, they do that, or on a certain multiple choice test. So if you multiply top and bottom by that, you will get negative square root 3 over 6. That is also an answer. So both of these are interchangeable. They are fine. It just depends on how it's going to be written as an answer.